Welcome to Carlton's Math Corner. Today we're going to continue our study on scatterplots. At this time, please make sure that you have your math journal, vocab packet, as well as something to write with. Our targets today is I can interpret data using scatterplots and approximate line of best fit. I can make a line of fit. So, first of all, you're looking at three different graphs here, and all of which are scatterplots. And if you were asked to draw a line to show the relationship between the data, where would you draw it? And this is something that you had to do in the last video. So we're just going to practice. Where would you draw this line? Okay, so I personally, let's start off with the first one. Well, this one, I would probably draw it just like that. And if yours was not exactly where mine was, that's okay. Because as long as yours is showing a positive correlation, and this one's pretty strong correlation, it's kind of between strong and moderate, but it's, there's definitely a relationship between number of hours of sleep and your test scores. So it looks like a good night's sleep does help your test scores. And it looks like there is a positive, so as the hours increase, then your test scores increase. Okay, so there's this one. How about this one? Your shoe size and your IQ. Whoa, this is some big shoes. 30. 30 inches, that'd be huge. But what I want you to notice, because I have some big feet, I'm about size 10. Quite large, but anyways, unfortunately, size doesn't look like it affects your IQ. I kind of wish it would, because then I would have a really high IQ. But all these points are spread out, so I wouldn't even draw a line of best fit. I would actually say that this is no correlation. Down here, amount of time spent training, and then your time running a 100-meter run. Well, I would put the line about right there. And again, it doesn't have to be perfect where it goes, but about there. And it looks like it's a negative correlation. As the amount of training increases, your time that you spend running a 100-meter mile decreases. And there is a strong correlation on this one. It is definitely a strong negative correlation. Okay. Now, once we've determined kind of where a line of best fit would be, I want you to notice what is happening in this problem. So here's a graph, and we don't really know what this data represents, okay, because there is no titles here or anything, so we don't even know, and that's not even concerning at all, because I just want you to focus on the line of best fit. Okay, I want you to notice like what steps are being taken here to show this equation. Like, where did this equation come from? Well, what I notice is we have a graph that definitely has a strong, negative correlation. But I want you to notice that there is a line of best fit that's been drawn. And once that line was put into place, it looks like there were 2 points that were taken from that line. And these must be the points right here. This 1 and 7.5 and 2 and 6.5. Those must be the ordered pairs for those points. Because if I go over 2 and up 6.5, yeah, that would be that point. And this one over 1 and up 7.5, definitely that point. Okay, so that looks like that was the first step was to draw the line, kind of looks like it. Second step was to find 2 points. And I don't think it matters which 2 points you choose because, I mean, a line goes on infinitely. So these 2 points were just chosen. So step number 3, though, what is going on here? Like, does this look familiar to you? Yeah, it looks familiar to me. I noticed that they subtracted the y's. So the y coordinates, 7.5 and 6.5, and they got 1. Well, -1 because they started off with the second one. And then divided by the x coordinates, they subtracted as well, so 2 minus 1. And when divided, they get -1. That formula, as I recall in a previous video, that formula is actually our slope formula, where we subtract the y coordinates divided by the difference in the x coordinates. And so it looks like we have a slope of -1. And then where does step 4 come from? Where does 8.5 come from? Well, B, I remember B stands for y-intercept. And so remember, y-intercept is where the line crosses the y-axis. So if you look at the red line, the one that was created, the line of best fit, it crosses at 8.5. And so I noticed that's where that number came from. And then the last step, it looks like these numbers that were found, the slope and the y-intercept, were plugged into the slope-intercept form. Y equals mx plus b, or y equals -1x plus 8.5. Okay, so let's look at the steps. What did we do? Okay, first of all, a scatter plot, either is given to us or we have to make it. And really, to make a scatter plot, we just need a bunch of ordered pairs and we just need to plot them. But, hopefully the scatter plot's given to us, kind of like the one here. This was given to us. And so it was pretty easy to go to step number 2, where we picked a couple points once we drew that line of best fit. Okay, so draw a line of best fit, choose 2 points. I would highly recommend if you could choose points that lie perfectly on the grid lines, that would be best, because then you're not dealing with any fractions or decimals. We didn't really have that option on this. I mean, notice this line really is not perfectly on a grid line. And so we had to use some fractions, or in this case, decimals. Okay. Step 4, we found the y-intercept. And step 5, we used the information that we had and we just wrote it in slope-intercept form. And let's write down that form again. Y equals mx plus b. Okay, so guess what? I'm going to actually have you take those steps and I want you to try to plot a scatter plot, first of all. So I want you to take these ordered pairs, okay? I want you to know that the top numbers, the hits, are going to be called our x's, and the runs are going to be the y's, okay? And you need to know that because, you need to know which way this line is, or these points are going to be graphed, okay? So hits are x's, runs are y's, and I want you to plot them on this graph. Then I want you to draw your line of best fit, and then I want you to figure out the equation for this line of best fit, and I want you to write it in slope-intercept form. Okay, you can do it. I have all confidence in you. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.